Hey guys, this is our section 2.1 on conditional statements. We're just starting chapter 2. A couple of reminders before you start watching the video. Please put your headphones, copy the notes carefully and neatly. I'm going to start being more picky about how I grade your notes. Highlight the important information. Okay, so I'm going to probably tell you what to highlight, but I won't highlight it myself, so you can follow the directions. And don't multitask, just give yourself the time that you need for this, for the notes. Okay, shouldn't be too long. All right, so let's start with what a conditional statement is. So a conditional statement is an if-then statement. Okay, if-then statement. We abbreviate, okay, if P, then Q. Okay, P is going to be the hypothesis and Q is the conclusion. Okay, so let's look at this example here. If you live in Walnut Creek, then you live in California. So you live in Walnut Creek. This is your hypothesis. So this is the P. And then you live in California. That's the conclusion. Okay, that's the Q. So always remember that hypothesis and conclusion. Okay, so let's rewrite as a conditional statement. Birds can fly. So remember, it's if then. So if we can say if an animal can fly, right? If an animal is a bird, then it can fly. Okay, if an animal is a bird, then it can fly. So how do we do the negation of this, right? The negation is always going to have the opposite truth value, okay? Okay, so let's take a look here. Write the negation of these statements right here. So the sky is blue, so the negation would be the sky is not blue. Jim is not tall, so the negation would be Jim is tall. It is sunny, negation would be it isn't sunny. And x equals 3, the negation would be x is not 3. Okay, so here are what I would highlight for this lesson, right? Conditional statement, the converse, the inverse, and the contrapositive. Okay, so as we talked about, a conditional statement is a if P then Q. Okay, hypothesis then the conclusion. So for example here, if Tim studied, then he passed. So this would be the conditional statement. The converse is when you flip the order. If Q, then P. So in this case, we can say that if Tim passed, then he studied. Okay, so here we have Tim studied, that was the hypothesis. He passed was the conclusion, so we switch the order. So if Tim passed, then he studied. Okay. The inverse is when you take the conditional statement and you negate both the hypothesis and the conclusion. So if not P, then not Q. This here means not. Okay, so again, we're abbreviating that there. So in this case, we can say if Tim didn't study, then he didn't pass. The contrapositive now is when we take the inverse, right, and we switch the order of the inverse, okay, or the negation of the converse. So if not Q, then not P. So to switch the order here, we say that if Tim didn't pass, then he didn't study. All right, so for the next page, I'm gonna ask you to work on it, okay? And then we'll go over this part in class. I just wanted to emphasize here, if the conditional statement, right, you have the hypothesis P, okay, and you have the conclusion Q, okay, and so you want to do the converse, which is going to be if Q then P, the inverse, which is if not P then not Q. Sorry, I forgot the arrow here. And then for the contrapositive is if not Q then not P. Okay, so go ahead and work on that, and we'll take a look at that in class. Let's see what a counterexample is. Counterexample is one example that shows that a statement is false. Okay, so for example, here we have find a counterexample for this statement. If an animal is a bird, then it can fly. Well, we can say penguin, right? A penguin is a bird, okay, but it cannot fly. Okay, so this is a counterexample because it shows that this statement is false. Okay. All right, now biconditional statement is when you have the hypothesis, okay, and then if and only if and only if the conclusion. Okay, so P if and only if Q. Okay, so we put P and then we use the double-sided arrow to indicate the if and only if, and that means that P is we have the hypothesis P, so the Q is true, now the conclusion is true, and also it goes the other way. If Q is the hypothesis, then the P is true. Okay, so conditions for a true biconditional is that if we have a true conditional, right, P, if P then Q, okay, we have the converse is true as well, so true converse. Okay, so Q, if Q then P. That's why we have the double-sided arrow. Now let's look at this example. Write a true biconditional if possible, if not possible, explain. So if two angles are supplementary, so we have here is the hypothesis, then their sum is 180. So one way we could do this is we can say, okay, two angles are supplementary if and only if. We can use a double F, if and only if, to abbreviate. Their sum is 180. All right, let's take a look at this next example here. It says, if you're a quarterback, then you play football. So we're going to try to write this as a biconditional statement. So let's take a look. If you're a quarterback, that would be your hypothesis. Then you play football. That's our conclusion, okay? So let's see, okay, if you're a quarterback, okay, then you play football, that's true. But if we go the other way around, if you play football, then you're a quarterback. Well, that's not necessarily true, right? You can play football and not be a quarterback, okay? So in this case, Q, if Q then P, right, is false. So that means it's not possible, okay, to write as a biconditional statement. All right, so now let's take a look at some examples here using definitions. We have a diagram, okay, and we're asked to find the truth value and then justify it, okay? So here we have angle AEB is a right angle, so AEB, yes, this is a right angle, okay? So this is true, and is true because of the definition of right angle, okay? So we have the definition of right angle. All these definitions are going to come in handy when we start doing proofs, okay? So AE and B, points AE and B are collinear. So we have A, E, and B. That is false. okay, because they are not on the same line, right? And that's the definition of collinear points, is that they need to be on the same line. Definition of collinear points. And then the next one, AC. So here we have here AC going this way, and then we have CA. CA is going to start here and go this way. Are opposite rays. Well, this is false, and they're not opposite rays because they need to have the same starting point. Okay, so by the definition of opposite rays, that is false. Definition of opposite rays. Okay, that is false.